Good afternoon. Yeah, good afternoon. I hope you are doing well. Time to pick something else. So I'm going to introduce the smart city solution with a focus on Nairobi right now, the smart policing for Nairobi city. But this does not mean that this solution is only restricted to Nairobi. We can pick it to any city, any location, and then we apply the same solution, and we have the application case for each. So the objective is to make urban crime possible and also make it hard for anyone committing crime or any incidents, make it impossible for them to hide. So I'm going to cover it in 3 parts. So we're going to quickly review the company, though this has been done before. So if you came in later, I'll just give you a quick brief, then introduce the solution, and then we look at some cases. So about Dahua, a global manufacturer, a world-leading video-centric smart IoT solution and service provider. Globally, number 1 in the market share for private listed companies. So when we talk about Dahua, let's focus on this region. In Kenya, we have 2 locations, one office, same location. So we have Mitsumi Business Park, where we have the Kenya representative office on 6th floor. If you have not been there, I encourage you to plan, come see. We have a lot more than what we could bring here. So we have the experience center. We have, of course, the training center. Trainings are going on daily. So in case you have any questions, we'll take you through. Then we also have the RMA, which covers now any issues that we would have with the product to make sure that we achieve 100% customer satisfaction. So speaking about the smart city solution, we're looking at key business concepts. That's the IoT connection. If you don't know about IoT, maybe you need to do a quick research, but it's the ability of different devices running independent tasks, and they're able to synchronize and transmit information, exchange information to achieve specific to achieve specific tasks. Then we have managing different locations. Of course, we have the population. If you look at the population of Nairobi right now, we have, I'm sure we have numbers. Then we have key personnel, person of interest. So if you blacklist my face today, how can you find me? How can you trace me? Then we have police patrol. Of course, every day we have police doing their routine patrol, but we have a solution that can enhance this. Then we have the key performance indicators for police, things like closing cases, things like evaluation and profiling users. So I'm going to take you through this. Though we have, on this solution, we have several ability centers, things like business empowering, IoT, we have AI. Of course, AI is coming out as a highlight in any solution that we are providing today. Then we have data exchange. This solution is not locked. If you want to integrate it with any other system, any other database, it's possible to do that. Then we have the data and computing center, where we are processing all the information we are collecting. You understand that from the day we install, let's say, a surveillance system, every day we are collecting this information. And 3 years later, it's a workload. So how do we process this? Then we look at several scenes of application. We have in the transport sector, we have in the building sectors, we have the government, we have security, then we have prison and correction facilities, then we have the command center. So these transformations, we just want to improve what we have right now, because we understand the city is running with or without the solution, but how can we transform it to digital? So that's what we focus on. So in case there is investigations, there is crime, how can we detect it before it happens? How can we prevent? In case, let's say the government, I've seen cases where, let's say you have the occurrence book, it's offline. How can we make this online? If you report a case in Nairobi on this side, maybe a police station X, can it be retrieved in the next police station immediately? Making everything online. So that's what we focus on, and we call it the IoT connection. So let's look at the product ability. Things like locations. Regardless of whether it's outside, whether it's inside, whether it's very distant, we can provide solutions that would apply for that. So for example, on the road, we have cases like maybe someone maybe hijacking a car, maybe such things. Then we look at traffic, we look at the square, then we say, let's say places that are restricted. If you're not supposed to go to specific parts of the city, what controls are we issuing there? Then we have travel facilities like the airports. How are we controlling that? Still, it's part of the airport to manage, but the government still comes in with security controls. So what we provide typical devices, the high front end, we call it the front end sensing devices. That is the cameras, panoramic cameras, long range cameras, and intelligent cameras. Underline intelligent because the camera can process these analytics on their own. We don't need the typical backend to process immediately. The camera can do that. But when we talk about growth of data, like we have 10,000 cameras within a space, we still need to analyze the information that is collected and processed. Then we look at law enforcement. Now the police, what can we equip with them? Things like drones. How many of us know that Dahua manufactures drones? Wow. Dahua manufactures drones. So from now on, you know. So there's much more you need to know. So that's why we try to introduce this. Then we still need to make sure that this solution is compliant. So in case we have any policies within the city that are governing, we still ensure the solution is compliant. So the key question is, how do we protect the city? And then we have something called the scientific layout. So what the scientific layout does is, we identify key points within the city, and within the key points, we protect and start. This solution is modular. That means you don't have to deploy everything at once everywhere. You pick key points, deploy, and then do it in phases and keep expanding on it. So when I talk about the scientific layout, we're looking at major roads, we're looking at urban entrance and entry points. So entry points like Mombasa Road, Uhuru Highway may be on the other end, maybe Thika Road. Those are key entry points to the city. So we protect that first. So we know who is in, who is out. The other part, we have the urban road networks, the long streets of the city. We make sure there is protection within this. Then we have sensitive areas, key areas, protected areas, let's say like Parliament, maybe State House. Those key areas, we make sure that we also deploy the solution there. Then we have maybe hot area with police cases. You've had places where we have police incidents, crime incidents. So these areas, we also make sure that we protect them. Then we make sure that we provide the device status. If I have 10,000 cameras, you can imagine if one went offline, what happens? So we provide solution to make sure that we cover this. Then we have the video status, the quality of video that they are capturing. If it's, let's say it's blurred, there's tampering on the video, we still need to detect this so that we make sure the solution is that efficient. Then we have the status of data. Because we are continuously collecting and updating our information, we make sure that we also ensure the quality that we can still continuously analyze, and we are receiving data from all source points. So that's quick review. And the objective is for anyone who is working 2 minutes, within 2 minutes, if we're looking for you and you're walking on the streets, we can find you. If it's a car, within a kilometer of movement, we need to track that car. I think if we do that, the city will be very intelligent and very smart, and will help improve the operations. So that brings me to the first quick question. If you are paying attention, I mentioned the scientific layout. So any 3 points in the city we can protect using the scientific layout. I want us to hand the mic to one person. He's the first person, so we give him the mic to respond to it. Kindly just wait for the mic.
I have 3 points we can.
Yes.
There is entry roads. There is sensitive areas like Parliament courts.
Protected areas.
Those are the protected areas.
One
and
more.
Also the streets.
Sorry?
Urban streets. Urban streets.
Urban sensitive streets. Okay, thank you. So that is at least to pick the points. Thank you. So we get a gift for him. Nice. Dahua wireless cameras. If you don't have a wireless camera in your home, you need to get one. Maybe even today. So the key points on the scientific layout is urban entry and exit points. We have the urban road networks. We have the sensitive areas. We have the hot area with police incidents. Then we have the high risk person areas. So remember the policy. Within 1 minute, we find you. Within 1 kilometer, if you're driving, we find your car. That's, I think, an improvement. Then still looking at the solution, we look at the AI ability. How much AI can we process with this technology? So we're looking at human body detection, things like face metadata. Can we tell it's a man, it's a woman, how was he dressed, did he have a cap, did he have a beard? All those we can analyze. So many attributes, more than 40 types on 8 items. Then we look at, for vehicles, we analyze this vehicle. What was the brand of the vehicle? What was the color? Maybe we could pick part of the license plate, but if you have the other metadata, we are looking for a blue car, we add a filter for a blue car. We're looking for an SUV, we filter like that. Then the technology will help us to quickly trace and detect these targets. If you're looking at motorcycles, things like motorcycle safety, is everyone wearing a helmet? That's a good question, right? So can the camera detect that? Yes, the camera can detect that. So 5 types, up to 25 different attributes on the motorcycle detection. Then we look at also the public security scene. So things like border control. You're entering maybe a restricted space. What was going on there? Then we have prison security. What AI can we apply? I'll give you a hint. Let's say in a prison we can do automated roll call. Every 2 hours, everyone is required maybe to line up, and then the camera does automatic roll call. We can achieve that. Then we have the picture quality, continuously analyzing and improving the image quality. Then looking at the hardware that we provide and the technologies, you can imagine face recognition and face detection. I'll just like to insist, face detection is the basic function that is required to achieve face recognition. We keep analyzing and capturing faces, and then we use that compared to a database. When we get its relative, maybe 75% close to someone's face, we pull out the list of persons. We continue increasing the accuracy, and we get the correct person. That's how you compare face recognition and face detection. Then we have video structure. So we are continuously analyzing the video. Things like walking patterns. Are you always running within the city? Are you walking calmly? So, such things, the camera can quickly detect and trigger. Then we have people counting. You can imagine like in a square where people are gathering maybe to do a demonstration. On a typical day, it's usually 50 people. But today, within 30 minutes, we have 300 people. You trigger an alarm so that someone responds to it even before it happens. Then we look at the other qualities. So in terms of the hardware ability I mentioned, the camera can process. But let's say we get a lower camera that's not doing the processing, we can have the AI box. So this AI box would do processing on even other cameras. Even if we have third-party cameras, we can apply our AI on them using now the AI box at the edge level. Then at the core level, we have processing the AI servers, the center AI processing. So after we record this information, we now start to process it continuously. Here we are doing even 1 million faces maybe in a minute based on the power and the capability of the servers. Then now, we have several algorithms that have been developed, and again, this solution we can provide. We can also give you the model, you train it yourself. Let's say we're looking at privacy concerns. We give you the model, the hardware with these abilities, then you start training its capability to achieve your requirement. That's also possible. Then I mentioned that we continuously collect data on daily basis. So we are looking at big data becoming a concern. So every day, we keep profiling users. We keep doing insight on different maybe application cases. In a typical carjacking, how do we respond? Such things. Then we do the star map. I'll show you the interesting features of the star map. So we keep exploring this information. Access efficiency. We can integrate this. Let's say we are running license plates in real time within the city. We can link it with the NTSA database, and constantly we are always cross-checking. If it's a blacklisted vehicle, we say it was spotted on Mombasa Road, headed to town or headed to the airport. So we continuously do that. So if you're doing, maybe we are following that vehicle, we can just silently track it and then plan to maybe get it at a specific point. Then we have data governance, where we have so many standards. Globally, we are required to comply to these standards. So our solution actually complies to these standards. Then we have the value of this information. After we analyze, we notice that every Friday on Mombasa Road, there is always an incident of car robbery. Let's now send people there to respond to that. The next time it's going to happen, we have already predicted because of the continuous patterns. So this can be automated in a way that the system just continuously collects the information, analyzes, and then gives you the patterns. Then now we have, let's have a look at this. A one map control center. Continuously we can give you this kind of view, where automatically you can switch in between the different dimensions, switch between the different sensors, and do the analysis. We have the all-in-one map digital twin. Digital twin is a virtual model of the city. We can build this. We have the GIS map, a two-dimensional, to get the real-time alerts popping up here and there. Then we have the AR video map. That's the augmented reality that we would model for the city. Then we have target tracking across different scenes. So while you're moving, we're looking at, for example, we have a PTZ camera there. Can it track you as you move within? Let's say it's a person of interest. Can it track them? So it will zoom in, even give us clearer metadata for analysis. So what are we looking at? Over 92 processes online. Things like real-time police alerts, case management, event management, where we have incidents, then the general management of these alerts. Then how many objects do we get online? Human analysis, we have the vehicle analysis, more than 133. Then we have maybe incident alerts. Then we have even monitoring the key areas. Then we have so many resources getting online. Police resources, like we equip the police camera with a body camera. If you have not seen our body camera today, make sure you pass by at the back there and have a look. We have it even connected to our platform. We can also do the demonstrations for that. We have maybe the police car. Of course, we also have the hardware there for the police car. Then we have emergency resource deployment. How do we send response? That is also there. Then I mentioned the IoT sensing. When we talk about Dahua IoT sensing, typically it's at the camera level. The camera will do its own sensing. Then now we have the profile center. So how do we profile the vehicles? Every vehicle spotted will get a unique ID in the system that will use that to cross-reference and maybe track it. Things like the trajectory, the relationship between that vehicle and any other vehicle it has interacted with, maybe the streets it has been to. We can get a yellow car today driving on a specific route to a specific point. Tomorrow we get a different car going to the same point. You see, we are cross-referencing information from vehicles, from different users, and then putting everything together. Then we have profiling of users. What are my movement patterns? How do I move? So we can profile and group people based on their relationships. And that ability goes to even higher extents. Things like on this insight, we are facing maybe similar faces. Someone mentioned twins. How do we differentiate twins? This AI can do that. Why? For instance, for the face, we can analyze 72 attributes of the face. Things like the length of the pupil, all those. So imagine a camera doing that level of analysis. We can tell this is person X, this is person Y. Then we have the data intelligence. Now after picking all those cues, can we reference it to maybe a specific face database? We continuously model that. Then now, when I click, let's say, Zephaniah's information, I get cross-reference information in this level. We call this the star map. I want you to be keen on how the star map would work. So today I made 6 calls to 6 people. I made call maybe to 1 technical engineer. I made call to 1 salesperson. So we use the star map to do this level of cross-referencing and strictly focus on key personnel. Like today, you see, like on this map, we have someone marked with an exclamation point. So these are persons of interest. So how many persons of interest did I interact with it today? Then we can even generate that and see, let's say it's a gangster, how do we get their relationships, the people they've been working with, maybe such. So we continuously analyze the different patterns and look at the relationships. So for every personnel that we pick, we do that level of analytics and profiling. So we use the StarMap algorithm, and this can be applied. So let's look at 3 types of data source, 6 types of vision relationships. Things like the person information, the vehicle ownership information. I'm sure there's a database that shows who owns a specific vehicle. Maybe the driving patterns, the routes. We have the group. Let's say I work at Dahua Technology. How many other personnel work at Dahua? Can we investigate also that level of those relationships? So that's the StarMap, which helps us in profiling our users. Please take note of this. Then I have arming and early warning. So for example, I'm notorious. Every time I go to Mombasa Road, I attack someone, right? So we can create early warning and arming. So the next time I'm seen within that area, the police get a pop-up, or the security force gets a pop-up that this person has been sighted in this area. Now they pay attention. They just mobilize their team to be ready to respond to that. So that's how we had used the arming and early warning. So we arm means we pick that information and just share. You've not done anything, but now we are watching you. Then when you go to a specific area that we know that incident has ever been, we trigger an early warning. Then you have the dispatch center. So when we do the warning, of course, we need to know who are the nearest maybe officers, who are the nearest security forces to respond to that. Then after they respond to it, let's say I send a police officer X to a site. Of course, he has the body camera which will capture that information on that site. But at the same time, while they are moving, while they are driving the police car is able to run face recognition. We have cameras that are doing that automatically. The police car is also running automatic license plate recognition. So if you're searching, the police may be on a different task, but his car again helps us to pick some other cues that we are looking for. Then once they respond to that incident, they take a picture and file, maybe this happened. So we have evidence. We also have maybe tracking of those cases. Then some application cases, so real-time people identity and creating library. So while the cameras are monitoring, we pick you in an incident, we directly add your face to a database, maybe of key persons, a database of VIP persons, such things. And then we have key suspect control. So I've ever been found doing maybe I've been found in an incident before. So I'm added, instead of the normal key person monitoring, now I add you to maybe a highlight database. This is a blacklisted face, or this is a person of interest. Now every time they show up, it will come with a different tag as a person of interest. So we compare this, both the police information that they've recorded in their system versus the real-time video capture. Then I insisted on the StarMap, and it's still coming up again. So we pick you, we look at what are relationships and the people we've interacted with before. And then now we cross-reference that information to give you the accurate relationships. And maybe if you're looking for groups of people of interest, then we trigger that. So with that, I want you to ask my next question. So what is the relevance of the StarMap on person of interest or suspect location? One person. The relevance of a StarMap, the algorithm. There's someone at the back. Yes, thank you. I thought we'll go back with that gift.
It's basically for identification of your relationships, mainly the characters that you've been moving around with.
Okay, thank you. That's correct. So StarMap is just focused. It's an algorithm that focuses on relationship identification and even looking for other persons of interest within the same scope. Then now let's look at the spatial analysis of suspects. So what do we analyze in essence? We look at the historical case information. We look at vehicle registration database, and then the real-time cameras that are tracking. So what is the ability? We compare that using the star map, and then we do maybe extra adding more information on a case. We have something we call a case file that can be built. So today we just collect information on you passively. Then when an incident happens, we start to analyze that information maybe in further detail. Then we have police force dispatch center. So we generate the case, we dispatch the police, and then the police goes to site to process any incident. Then after that, we archive that case. We have archived it, but we have not discarded it. So in the event that it comes up again, we compare with what is in the archive and how can we respond to it. So things like number plate recognition alarms, face recognition alarms will become much prominent to help with first easing the support. Then we have the command and control. So we can do regional command centers. We can do main command center, let's say the main office. So what do we get there? Daily intelligent alarms. We get there, wartime, the command and dispatch alarms. Other alarms that we can also get, we are just not looking at the crime itself. We're also looking at things like water level detection to detect things like floods coming up. We're looking at production monitoring, let's say the pipeline tanks, all those, the oil tanks, all that. Then we have fire prevention. So that's another cue. Maybe areas that are prone to fire outbreak, we deploy some thermal cameras and fire monitoring cameras. Then how do we upgrade this? We even add extra add-ons. I mentioned that Dahua has drones. So when we detect that maybe there's an impending fire, we trigger maybe the drone to go get a quick view, and then we get that information back. Remember, as the drone is doing patrol, we are streaming. Even the drone's ability has been improved to the sense that it can also do automatic patrol. Today, I set it every 11 to 12, it does a routine check, then it goes back to the docking station. So that's also a possibility. Then we look at the general picture is we have a converged communication. One system, everyone can access to do the different tasks. Then we have the digital twin, which I told you is the AI modeling. Then we have data integration capabilities, where we can also interconnect different databases. Then we have multimedia integration, where we can pick images, we can pick audio, we can pick different data from different databases. Then we have the dispatch. So, for instance, if we are deploying in Nairobi, this is how the typical would look like. Constantly just capturing information and the analytics. So let's look at some key cases. Because I mentioned it's smart Nairobi policing. So we provide, for example, the urban airports. That's the Jomo Kenyatta Airport, Wilson Airport. Then we have the urban main roads, things like the Thika Superhighway, Mombasa Road. We have Wayaki Way. We have maybe the different bypasses, the 4 bypasses. Then we have maybe the key areas within the CBD, KICC, the city square, the railway station, maybe the key streets like Accra Road, Moi Avenue, such. Then we look at the sensitive areas like the hospital, KNH. We have Nairobi Hospital. We have University of Nairobi, Kenyatta University maybe, and these other areas. So what do we deploy? We can deploy high HD PTZ, that is up to 32 megapixels. Then we can run like capability of 32 faces per frame. Then we have the mosaic to protect key person. So what the mosaic does is we'll get a typical image like this. So this typical image, we still have that information, but it's blurred out. Only the approved personnel can now see who exactly is this. So we can also provide that level of privacy protection. Then our product previously has had things like the drop test, where we run this because we mentioned we look at R&D. So breaking them becomes another idea that we try to handle. Then I mentioned the panoramic monitoring. This is the typical panoramic monitoring and the drone monitoring. So that's how we will deploy the solution maybe in the city so that we can quickly and easily respond to incidents when they come up. Then we're looking at a city. The amount of data that we're picking is quite huge. So how do we do that? So we have to develop a storage, a local storage. Then we give you the cloud infrastructure to deploy maybe in a specific data centers or several data centers. So we can do maybe local storage within the device up to maybe 6 months. Then central storage we do 2 years, or as much as you want, or as much as the budget can allow. Then now the brain design. This is the command center, and I want to quickly highlight the command center. Then I ask you a question. So pay attention if you can answer this. So we have at the command center, we have several business centers, things like the business enabling center, the operation index, the full connection center, big data center, and then intelligent computing, then city command center. One map, one big screen, we can access all this information on one single dashboard. In the command center, we have the data center, which is modular. We can do it from one location or several locations based on also bandwidth and also availability. We have the monitors, Dahua does monitors from 21 inch up to 98 inches. Any size you want, we'll give you the options that we can provide. We have the network keyboard. This is to control the panoramic and PTZ cameras. So we can use that. Then we have the KVM. For example, police have a mobile command center. We use the KVM to give them the same interface that is accessed at the main headquarters. Then we provide LED and LCD products. If you've not seen any of those, please also pass at the back there. We have several LEDs, fixed, rental, indoor, outdoor LEDs. Then we have the control, that is the visual control screens. So we can provide the decoders, we can provide the matrix to help with achieving such functions. So now I'll ask you one question, then we review some cases that we've done, and then finally I take 3 questions. That's how we're going to finish. So any 3 key products used in a command center, one person. I want this side, at the back, behind you. Please pass the mic. So any 3 products for command center to be used in city monitoring?
So we have KVM,
KVM,
LCD and split screens.
Thank you, yes.
And then now we have the third one was
The?
data center.
Sorry?
The convergence.
The last one?
Is converge center.
Sorry?
Converge center.
No.
Data center.
I want a lady to help him. There's a lady at the back. Yes.
We have the LED and LCD screens.
Yes.
We have the KVM.
KVM.
Network keyboard.
Network keyboard.
And monitors.
Monitors. She's doing more. You want to add another one? Thank you.
enough.
So monitors, LCD monitors, the splicing units, the KVM, the network keyboard, then you have the controller, that is the matrix and decoders. So a gift for her, please, and let's clap for her. Thank you. Thank you. Now, to summarize, a look at quick successful cases. So we've had this typical future city. Look at the video. Look at that deployment of the command center. So we have different cities, the future city. So this kind of deployment, we have achieved that before. Then we have the control room, a tailor-made or custom dashboard. We have ANPR and face recognition for different key areas. Then we have the solutions that we provide, the traffic control solution. We have the outdoor signage. So if you're doing information release and digital advertisements, you can consider the signage. We have both indoor and outdoor. We have scooter control. We have the panoramic camera. Then access control highlighted. Then we look at the safe city in Mexico, where we have the C4 control center, monitoring the main roads, the community, the square, of course. We have the park, the hospital, and also the border. And look at the highlight of this solution. Case closure rate increased. Emergency calls reduced because now we have more control. Then the fear of violence also has grown. Actually, it was at the lag here, then it went down, then it went up. So the solution is giving us that highlight. So we have the peace overall score over the time since 2015 up to 2023. So you can look at such cases. Then now we have the Hangzhou Smart Policing Project. Hangzhou is one of the smartest cities in China. We have the camera coverage, which is also highlighted. We have the intelligent upgrade. We have the data situation, real-time data situation. And the highlight for this solution is we have valid alerts. We have crime-related property, so crime-related issues going down. Valid alerts also going down because now we have solution. Case closure going up. Then we have efficiency of the police also going up. So those are some of the highlights that we would like to mention for the city case. Now, 3 questions, strictly 3 questions because of time. The first question at the back, the second question, this side, one more. Okay, let's answer the first one at the back.
Yeah, thank you. I have 2 questions. Probably you could count that as one so that you give opportunities also for 2 more. The first one is about the storage. I saw the structure that you have for the database that you have collected within a period of time. Assuming it grows and gets to some thresholds that probably you might need to offload. We know, especially in CCTV, you would want to probably be able to retrieve instances. And some of them could have happened maybe some time back and you want to have some footage. Is there maybe some kind of offloading to cloud? Is there a cloud maybe ability for your storage to offload the excess data to cloud? That's one. 2. Sorry?
Yes. Second question.
Yeah, the second one is about, we are doing a lot of policing, but I have one case that I would wish that if you can be able to share a solution to, it's a manufacturing company, it's an industry. So they are looking for a solution of counting bags. Say, for example, you're producing your product and comes out in terms of bags from the factory to your warehouse. Some of these bags are they have 2 features, 2 different features. Some of them are 10 kgs, others are 50 kgs. Over and above that, some of them come out not of the same weight, but sometimes lesser than the capacity allowed, and sometimes some of them are more filled than are supposed to be. And some of them are distorted to an extent, they're even kind of spilling the product from the bags. So I was looking for a solution to answer that, and probably you could be having one that you can actually share with us. Thank you.
Okay, thank you. So let me respond to that. So 2 questions. The first one was storage related. So number 1, we understand that storage is quite expensive, especially CCTV storage. If you're looking at the videos, the data that we'll collect will be huge. So how do we optimize this and help to offload it maybe to some other site? So number 1, we look at the compression on the cameras. Our cameras have even, we know about H.264, maybe H.265. We even have AI compression. We don't need to pick continuous video of this area if nothing is changing, right? So we use AI. We don't need to pick that. We only save the changing information. On the other side, because storage is quite huge, we provide storage servers starting from 16 bay, 24, 36, 48, and up to 85 hard disks. Each slot carrying up to 25 TB. And this can be interconnected. You can have several servers running that huge storage. Now, offloading to maybe some other cloud platform or other storage service, the technology is capable. We can provide you an interface that you can now upload to maybe another storage. We can also provide you the support both at the hardware level and also at the software level. I hope that clarifies that. Then for the second question, we have manufacturing company. We have something called the Dahua Industrial Logistics Park Solution. When you have time, please come. Let's arrange and do it. We have a very smart solution that handles from production up to the delivery level. So we have a solution for that we can offer. So you're welcome. Our account manager, please take note of that so that we also present and give a solution. So thank you so much for this. Now the next question.
Yes, hello everyone. My name is Duncan Musimi. I've heard you mention about the drones. I would like to understand if DAWA, the drones you are offering, do they encompass specifications to complement GIS mapping to digitize, map and manage power utilities, entire distribution network? For instance, substations, transformers and power lines. Do they have LIDAR sensors and so forth and so forth? Thank you.
Thank you for the question. So just to respond to that, we have drones. We have different types of drones. We call them the industrial grade drones. They can be used to monitor such things. Long distance power lines, we can. Substation monitoring, we can. We just need to create a routine and also look at how far they can go. Also, the other factor that usually would affect the drone is the payload. How much weight is it carrying? Because that would affect the flight time. If it's too heavy, then of course not going to fly for so long. So we have different solutions. We have the long distance. We can provide this solution. And also we take that opportunity to discuss and see. I'm sure you have a perspective that we can look at. So again, back to our account manager. Then the last question.
Let me take you back to storage.
Yes.
I don't know whether it's only me who encounter this problem that DAWA is the main product that I think the largest that we install in Kenya. But unfortunately, we are having a problem when it comes to storage and especially hard disks. DAWA specifically does not sell, or I have not come across any hard disks for surveillance. And for that, and I'm lucky we have the channel partners here, we either buy Seagate or WD. But nobody in Kenya offers warranty on those hard disks. You buy it from the shop, you cannot even take it back the next day if it has a problem.
Which shop is that?
All of them are here. They can tell you that they don't offer any warranty on hard disks. So can we have maybe a partnership between DAWA and maybe WD or Seagate? I have seen it with Hikvision. And it can be sold via maybe the channel partners, and so that we can have warranty on hard drives.
All right. Thank you for that. I will not respond to that. I think I need an account person who is the technical manager who will respond to this because of it's not city related directly. So kindly for the hard disks. But I want to end there. Maybe we're going to have a discussion on that specifically. Thank you. I'm sure we'll get back to it. Only 3 questions. Unfortunately, if we have more, let's have a discussion at the back. Also, maybe let's do it from the control center. Thank you.